Hi guys, I'm Asif Ali and you're watching CGHOW video, and today I have created these rotating random color triangles on this cube shader with help of HLSL, and I converted that code with nodes in material. So let's start this tutorial.
CGHOW. CGHOW.
First of all, subscribe my YouTube channel and also click on bell icon so you will receive all new video notification. So I have this empty project and I will start by using this code from shadertoy.com with this from this guy heavy brush, and I'll use this code in Unreal Engine as HLSL. So let's create a material first. Triangle. And if you want to use a custom node, you can directly connect it here and return 1, so it's showing you white because for our RGB it's taking the 1 value. And if you want to change the color, you can type return float 3, then put your colors. This is white again. If I hit enter, it will remain white, but if I change some value like make it 0, so it will be yellow because R and G are 1, and now it's red. So this is how you change the color or put something in here. Okay, so and you can also do one thing, so return color, or you can say return curl, and now here in input make up input call with the same name, and then take a 3 vector, connect it here, and now you can change the color from here. So this custom node taking the value from this call input, and whatever it has, it's just passing it through. So this is how it works. So now in here I have this code, so I'll just copy this whole code and take a notepad plus I have, so I'll just let me just take a new paste, and I can go to languages and set to HLSL. Okay, you can install this notepad plus, and you need to also install this HLSL language. Okay, so first thing, what I don't need here, this line I don't need here, and rest of the code, this frag code is your texture coordinate. This is the same thing, you have to name it same. Then with my notepad, oh, did I just close my notepad accidentally? No. And this eye resolution is just a resolution of screen, so you can just put the 1 value for this. And then this is the same texture coordinate resolution, and a 10 will be a 10.2 in HLSL, and then everything is cool. And vector value will not work here in material, but if you are working on Niagara and you are using HLSL in Niagara, then you can use vectors, but here you cannot. So you can just replace by, there will be, okay, I'll just manually do it. So this will be float 2, this will be float 2, float 2, and this will be float 2, and this will be actually float 3. Okay, 3. So our code is ready to use, and let me just copy this and paste it here. I'll take one more custom, connect it here, and then paste it, hit enter. First thing, we have to mention our texture coordinate, this frag code, and eye resolution. So I'll just copy this name, and here I'll move it up, create this input, and this will be my texture coordinate. Then this eye resolution, copy and create one more input, paste it here, and this is also 2 vector because it's showing you this dot xy 2 vector float 2, and I'll just make it 1. Still it has error, and let me check. So first thing, it's saying this about this UV. So here if you see undeclared identifier UV, this, so you can mention it here if it's saying that float to UV is equal to 0. Then it's saying frag color, so you need to remove this and change it to return, and is equal to also will be removed. So return, hit enter. Okay, return float 3, and then I have mistaked spelling, I think here, this one, and let me check. All spellings are correct here. Which spelling oops. Okay, this one. Okay, now one more thing, because in GHLSL, because this is float 3 and I have, like, give me some example, let me give you an example. So you can write like this, float 3 and float 3 1 for GLSL, and it will take 1 for all your RGB. But if you are working in HLSL in material, here you will type float 3 1. You need to mention that 3 times. Okay, so this code, this smooth step code, should be retyped 3 times, but that will look very long. So to make it short, what I'll do here, I'll make float s is equal to this same code, copy, paste, and here I can type that as 3 times, s, and we got our triangle working. So this is how much you have to change. Now let's reduce this code even more, and see this thing, this code is making these UVs a center, and basically to make that center there is one more way. If you have texture coordinate and this is your point, if you subtract 0.5, it will come to the center, then you can divide it by 0.5. So this is your center, and you can just use these 3 things in your code instead of these 3 lines. So here what I'll do, I'll remove this all code from here to here, and I'll say UV is equal to minus 0.5 and then divide by 0.5, and I'll just, so this is the same thing, and let me hit enter, and it's not working now. Oh, I need to call. It's working. Semicolon. So you see, I have reduced these three lines also. Okay, and now my code is just minus 0.5 and divide by 0.5. So this is a smaller code now. Okay, so now we have this small code, and let's start creating this with nodes so you will understand each line how it's working. Okay, so first I'll copy this code, this whole code, copy in a comment box so I can check that again and again. Make it black. Okay, so first thing, you need to make the UVs. I just deleted that, I should not have, but I'll create that again. So subtract 0.5 and then divide by 0.5. So this is your UVs. Okay, and I can just rename it. So here, after this divide, this is your UV. So first line done, this is how it's working. Then second line is just making an integer and putting the value 3. So if I make one parameter, and let's make it parameter and call it n, and default value is 3. So second line is complete, and these things pi 1 and pi 2, you can just take the pi node and the value, you know, 3.14. If you open this, you can see this. So this is your pi, and you can duplicate this again and put the 2 here. So this is your pi 2, and if I take the debug scalar value preview, you can see this is pi 3.14, this is pi 2 6.28, same value. So this is your pi 2, pi 2. Pi 2. After that, we need to make this float a. So here, let me just move this here. Float a, that value is attend to UV xy plus pi. So I have this UV. So, but you can take this from here also. So I'll take R10 and shift C for the mask. Take the xy value separate, connect, and this will make this an arc like this. So, and plus pi, so add this pi over this, so your output is this. And to check the output whether you are doing it right or not, press A. You need to check this line to visualize. So my output looks like this, and in this code, let me duplicate this for just backup. And here, if I preview instead of S A, and you can see this is exactly same output what I have here. Okay, then we need to make this R, and R is 2 pi divided by float n. N is 3. So 2 pi is this, so divide by n3, and this will be my R. Okay, then we may need to make this D, and it will almost done. So to make D, in D there are two things, this chord and this length of UV. So we have already UVs, this is our UV, and we can take the length, put it here, connect your UVs, and this is your length of UV. And to visualize it, you can take multiply and check, it is your length of UV, because UV start from 0 from the center. You can see we made that from center, so this is making from the center. Now this cos, so first we need this cos, floor, and these things. So first we need to make the inside the bracket. So first thing is A divided by R. So this is my A, so I'll take the divide by R preview, and then plus 0.5 and floor, because this bracket is for this floor, so floor, and then multiply R and minus A. So I will multiply R and subtract my A. This is my A, and we got this output. And you can visualize this also. So R, this thing D without multiplying with length looks like this. So here if I remove this length from here for now, copy and delete, and visualize our D, it's slightly different because we have the cos also here. So I'll type the cos. Okay, without cos, let's check without cos first. So now this is exactly same what we had here. So now with multiply with cos also. So with cos it looks like this, and here cos it looks different. Okay, so there is a problem, and we will check. But first, because after this cos is multiplying with length, so I'll multiply this thing with our length, this coming like this. Actually like this. So after multiplying this thing, my output it looks like this. And here if I paste my length code here again, this look like this. So there is a difference, and their difference is in cos. So how to fix that, this cos? Because all our my nodes is perfect, because there is some difference in this cos and what is written here. So you can do one thing, you can take a custom node and you can make float D anything is equal to cos T. T is my input, and return float D, and I'll make a input T. So whatever I put here in this node, it will give me the output after the cos, and instead of this cos I can use this, and you can see the output is same now. So you can struggle with that cos, why my output is not same. So you can do this because I have already struggled with it. And now last thing is smooth step. So you can just take the smooth step value, and values are 0.41, 0.4, and you got the triangle with nodes. So this is chord, this is node, and you can do a lot of things with this now. So let's connect it here in emissive and make it unlit, two-sided on box. First thing, you can make lots of triangles by changing your UV. So for this UV is just a single UV, you can make it multiple. So multiply it and take the frac of it. So if I show you, it is still 1. So if I make it 4, it's now 4, and you can use it. Now you have 4. Okay, and if you want to randomize the rotation of these, you can take the custom rotator, connect it here, and center will be 0.5, and this is your angle. And if you change, all triangle will rotate at the same axis. So what you can do, and let me make it 0.5 on the same axis, see, 0.2, 0.5. I want randomize. So what you can do, because this is 4x4 UV, you can take a texture, any texture that looks like noise. So I don't have noise texture. Let me import from my D drive. I must have noise. So this is default basic noise. Let me save all and drag it here. But this noise is very noisy, and it should be pixelated and should be 4x4 pixels like this. So to do that, you can multiply your UV, then take a floor and then divide it by same value what you have in your multiply, and connect it to your texture. And if I put 4, it will give you 4x4 random noise. And now you can use this in your rotation, and if you see, every triangle is differently rotated. And you can do one more thing, you can add a time in this and then sign, so it will make 0101 like this. And now if you put it here, it will rotate them. And you can reduce the speed by multiply time with a lower value like this. So now this 4, and you can also connect this, will change how many you want. Okay, so let's say 10 or maybe 8. And you can also random colorize it. So let's say I multiply it with color. Let me put it here, 3, and I take the red color. So these are all red. So if I take the hue, and in the hue value, I again can take this thing, randomize color. If you take this, it will just randomize color once. It's not animating, but this value is animating. I can use this here. Okay, and if you want to make bright, you can do one more thing. You can multiply this color and then multiply this thing with high value like 100, like this. Or you can saturate also, so it will be just 0 to 1 here. That can give you different output like this. It look cool. You can do a lots of things still. I'll just hit 20. This is our shader. Thanks to this guy who put this code, and I hope now you understand with these nodes how this thing working here. Okay, so this is it. I'll just stop this video now, and thanks for watching. And maybe in coming days I'll make more HLSL video, basic one, so you will understand. So thanks for watching, keep learning, and bye bye.